Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Hello and welcome. Thanks for coming to another episode of DevOps Accents. Since you are already here, make sure to like. And if this is not the first time you are listening to us, make sure to be subscribed. We are MKDev, where we provide DevOps, data, and AI consulting and engineering services. And we recently launched a limited program for free cloud cost audit that is especially useful for those who want to make the most from their infrastructure ahead of major releases or investment. It works regardless if you have AWS or GCP or Azure. How to apply is in the description. Check it. And enough with the promotions. Here on DevOps Accents, we discuss all things around industry and beyond. And today, Pablo and I invited a very special guest, Ignacio Echavarría. Hi, Ignacio. Welcome to DevOps Accents.
Hi, thank you, and welcome.
Hi, Pablo.
Hello.
The reason why we invited Ignacio is because we have many interests in many different fields, not only cloud, and not only us, but our listeners too. We all geeks, after all. And Ignacio is an aerospace engineer. He spent over a decade at Airbus certifying and designing power plant system for cutting-edge programs like Airbus A400 AIM. This is like a big-ass military transport aircraft. Everybody knows about it. And the A320neo airliner and the most recent E-Fan X hybrid electric aircraft that was unfortunately shelved recently. And currently you are focused on full electric and hydrogen electric hybrid developments at Dovetail Electric Aviation as CTO and head of engineering. Am I right?
Yes, that is correct. I'm also in the cloud, not in the cloud.
Nice. And we just couldn't miss the opportunity to talk to a person who actually invents new cool future hardware for machines that fly in the sky. How did you end up there? I mean, for most of us at MKDev and those who listens to us, becoming a software or a cloud engineer was an organic evolution of the industry. You learn as industry grows, and we discussed this many times with Pablo and other guests here on the podcast. But for you, it was different, right? Your career started at the university. What is the choice for you?
Yeah, exactly. So I always knew I wanted to be an engineer, but then, engineering is a big field. There's lots of things to do. And at some point I decided, aerospace is really, really nice. I mean, all the airplanes are cutting edge technology. If you want to make something that's really, really cool, that would be aerospace. And that's where I became, aerospace engineer. And I was lucky enough that Airbus, one of the biggest right now company in the world in terms of aerospace, hired me. And therefore I started working with Airbus. In Airbus, you work with big aircraft, the ones that everybody knows, the ones that everybody takes. Well, not the military ones, but at least the other ones. Everybody's been on an Airbus at least once or several times. And yeah, it was really, really interesting. And it's a world which is, complete technology driven, very, it's not very fast paced in the sense that things move slowly because of what we'll talk afterwards. But it is, always focused on technology, on what we can do with these magnificent machines. But it's fossil fuel based. It's polluting the environment. It's something that we all want to fly. We all want to travel to new places. We all want to use the aircraft because they're really useful. They're part of the economy. But at the same time, we need to find a way to make them cleaner. And that is a challenge. It's really difficult. So when the opportunity arose at Airbus opening up the electrification and decarbonization efforts, I was lucky enough to be able to join and start that foray of trying to understand, how we can make the aerospace industry be cleaner in a sense of less carbon emissions, less contrails, less things. And then I was able to work on that, and then moved on not never forgetting Airbus, I went on to different startups to also work on electric aircraft and trying to, you know, to fill that gap and try to, you know, not only love my job but also contribute to the future of that industry.
Yeah, we will get to that, but I wanted to dig deeper into your head, like because I assume like you have to have a certain like state of mind and a certain way of thinking to want to be an engineer at that early age, because for us, when the programming is like is a way to fulfill your curiosity for us, and then you and new things appear and you learn them as well, and then another thing, and the way how cloud industry and the computing evolved in the past 10 years is you cannot compare it to anything else like on the world, and the way how we have to learn, like you cannot go to the university, spend 6 years learning cloud technology and then be released like, oh yeah, I can find a job. No, your knowledge is already too old to find a job today. This is a different thing for you, like
It is.
yeah, and the aerospace industry hasn't evolved since like, I don't know, a lot in the past 50 years, and you can spend 4, 5, 6 years learning basic, because the way how we fly, the way how aerodynamics works, it doesn't change. It's a basic physics, and you have to learn this and to understand this. And I mean, you need to know that you want to do specifically this earlier, before you get to work on what you're working today. How was that? Like, how did you understand that?
Yeah, what I would say is that I think the first thing is when you want to be an engineer, you usually know you want to be an engineer because you see all these machines working, whether they are computers or aircraft. You know, you see a fighter jet, or you start wondering, how does a computer work? I mean, why am I able to play a video game just on a piece of plastic? And if you have that curiosity, you start understanding that there's lots of things that need to be done, and you know, working on the shoulders of giants and being able to increment things, and you know that engineers can actually build things and solve problems, and you know, make things which change the life of everyone, change history. So in the end, that kind of when you're a kid makes you think, okay, I want to be an engineer. I want to be part of that path of people that have been changing the world slowly. And that was, in a sense, why I wanted to be an engineer. Then what type of engineer? That was still open at the time. And then when I was in university, I started, you know, seeing different things, and I could choose between different industries. And I thought aerospace was really one that you know, takes is really interesting. It's really good technology. It's also something where I could make a difference. I thought so. That's why I went into aerospace. One thing to mention is that aerospace engineering is difficult to define, because many people think, you know, every aerospace engineer is the same. But in an aircraft, as you can imagine, there's tons of things to do. There's people who are very mechanical stress analysis, and they need to make sure that nothing breaks. Some people are very fluid dynamics, or even handling qualities, understanding aerodynamics, understanding flows inside the aircraft. All the people are thermal. And then we have the electronics engineers that need to work on the computers, make them safe, make them robust on the software. So in the end, being aerospace actually doesn't tell you what I do. That's the difficult thing. So I know people, you know, when you go to Airbus or Boeing or any of those, you will have a complete set of every type of industry you can think of, except for nuclear. I mean, we don't have nuclear power plants in the aircraft, but everything else you probably have something linked to it on an aircraft. So there's many paths to become aerospace. Many people in aerospace are not aerospace trained, are just you know, mechanical or software or whatever, and then they become this. But then there's the people who need to understand the full system, like the complete aircraft. Then you need to be able to kind of understand everything. You need to be able to understand structures, interaction between fluids and structures, dynamics, software, safety, and all these things. And that's you know, the more the architecture type, more systems engineering. And in the end, you all together make an aircraft. Aircraft are just big machines, hugely complex machines, and therefore you need a bit of everything. So there's not one path, there's several paths, and anybody can become this if they like it.
And Ignacio, one question, because the first time that I talk with you, you know, for me, it's okay. I know many companies, you know, because let's say that my job is to know companies and to talk with companies every day. And everyone is doing nothing. Let's say in this way that what everyone is doing these days is is I say nothing because really I do something that is virtual, so there is nothing physical. There are a few companies that are really doing something that is tangible that you can touch with your hands. But really few people. I met in these days, a super nice guy who is doing a device to climb, and you have in the gyms, but few of these devices are physical, and what you are doing in your startup is something really crazy, because when you explain to me, it was something like it's like your brain explode. So then, what is this path when you decide? Because it's true that the carbonization of the airplanes moved to these electric engines, but what is the movement of this path for you? Between I'm working in Boeing, and then I am in this startup that is going to do what you wanted to do. That is fantastic.
Yeah, how the evolution works for you, because we learn new thing and we decide to start working on new things when a new technology appears, or we invent something ourselves. Like there is an evolution. In your case, it was like a little bit different. Like, what was your motivation and how you upskilling happens?
I think it comes back to what I mentioned before of, when you're a kid, you want to change the world. And when you start working, you work on what you need to do. There's some work which are more interesting than others. The work I've done has been always pretty interesting because I was working on new developments. And, now every time I walk on an aircraft and I see it's an A320neo, I know I've worked on that. There's a pride in it, which is something which maybe when you do digital and just see your web page is not as much. But in this case, it's something you actually fly on that aircraft. It's really unique, potentially. Although many companies do things that are really amazing and unique in terms of hardware also. But there's something in the industry that is, it's still kerosene based. It's one of the culprits of global warming. And if you want to make a difference in aerospace, it's not going to be by just sitting down and doing the same old thing. You need to be a part of the team that thinks out of the box and just tries to solve the problems that exist. And yeah, when Airbus decided to, work on that, I was really happy to be part of it. And then going to the startups was more for, to try other things, I still have ties to Airbus. I'm still happy, I talk to them, and maybe someday I'll come back. But definitely, what's true is that startups do have a faster way of working. And at the time, I wanted to check it out. And, you can do crazy things with startups, which is a bit more difficult with some of the big companies. Although there's ways in the big companies to also work quickly. They're starting to implement some fast-acting ways of working.
All right, let's talk about that. Now that we learned that you are a very qualified engineer, I can say that finally I have a proper guest on our podcast with whom I can talk about Taylor Swift.
About what?
Taylor Swift.
Taylor Swift. Oh, I'm not sure I can help too much, but...
No, you can. Whenever Taylor Swift appears in the news, there's always this conversation tied to her appearance that she creates a lot of carbon footprint whenever she travels. Like, even there are that jokes, like, even when she needs to get to her kitchen because her microwave beeped, she takes her private jet and flies to her kitchen. So this carbon footprint is in the heads of everybody now, and there are a lot of talks about it. But do we really understand the issue, the problem with that, or is it just a joke, or is it really something that needs to be?
So I think it's as always, it's the answer is gray usually. So the first thing, let's go to the physics. So there is evidence, and there's lots of studies showing that aircraft operations, especially the kerosene-based operations, are damaging the climate due to three things. In fact, many people think of just one, but there's three things actually impacting. And they're, depending on the analysis, they're more or less one-third. One is the one that everybody knows, CO2. Combustion creates CO2. Therefore, turbo machines, which basically burn fossil fuel with air, create CO2. That creates what we all know, the CO2 creates issues in the environment. Second one is the kerosene, or the fuels. They have other elements like sulfides. They have there's nitrogen on the air and everything. With the combustion, they also create particles. They create soot particles. They create sulfide oxides. They create nitrogen oxides. They create different things that also affect. And in fact, this is weird because depending on the altitude, NOx is good or bad. I can't remember right now if it's good when it's high and bad when it's low. I think that's the case, but maybe the other round. So depending on what the atmosphere, it's actually good or bad due to the for the climate change. The third one is contrails. People don't think about it, but when you see aircraft flying and you see these white plumes behind them, that's actually just water condensation.
Yeah.
Due to the fact that there's particles on the air and the air is moist, they condensate and therefore they create these little clouds, which, because there's aircraft flying, they actually create a little bit of cloud effect, and that creates also changing climate.
So sorry, those clouds that everyone is telling that the people is
those are not, as far as I know, they're not Bill Gates trying to send the drones so that we breathe and become.
I wanted to know, because everyone is talking about those clouds.
Contrails actually are condensation trails. They are water condensation. I mean, all the aircraft, you will see them become black. That's more soot and things like this. But usually when you see them, in fact, when you see them, they're usually not they're behind the engines, because the engines have different air temperature, therefore things condense differently. And also they have these particles that make the water condensate quicker in that respect. But they're basically water. They're basically a cloud.
Okay.
I always found this conspiracy very funny, because when I was 5 or 6, I don't remember exactly, I asked my father about those, like what is that in the sky, and he taught me how to understand what type of aircraft is flying above me by the type of the contrail, because depending on the number of engines and where they're located, the contrail is kind of different. And I learned that those contrail are created by the engines, and it's not someone spraying something from the tank or something. They are really different.
Yeah. They can also be created by just the wings, but it's less. I mean, the more obvious one is the one behind the engines, but it can also be created by just pressure of the air. In fact, when it's wet environments, even a glider can create little contrails, which are due to the pressure changes around the wings. So there's some cool images if you want to look at those those things. But yeah, so coming back to the question before, so yeah, it's true that flying an aircraft creates different things. It creates soot, it creates CO2, it creates contrails. So yeah, taking an airplane will actually pollute. That's what it is. Same as taking your car will pollute. Now the question is, do we, and also using your microwave pollutes, because you need to get energy from somewhere, and that energy probably comes from a gas station somewhere, and therefore everything we do, just living, actually just creates methane with we pollute. So there's definitely different levels. Now, whether people like Taylor Swift or Jeff Bezos, when they fly, they pollute, definitely. The question, which I cannot answer, is, do they need to? Because they move the economy. So if Jeff Bezos from Amazon needs to go from place A to place B because of something from Amazon, maybe he wouldn't actually need to take a car with 4 other people and therefore have 4 cars. So it's a difficult question to answer. It's true that if we had trains everywhere, or teleportation devices, we would use it and then have no issue. But every time Taylor Swift moves, it moves millions of people.
Yeah.
I mean, it's an economic change.
Yes, because even this week, Eric Smith, one of the founders of Google, he said that that because Google has doubled the amount of CO2 emission because of the AI. And he was telling this week that they need to dismiss the climate goals, because the idea is, okay, we had a goals we need to reach because of this climate change, but AI appear, and it's the same as you're telling. Okay, what can we do? Stop everything because of the climate? The idea of Skin, it was, let's wait until the AI reach a certain level of seniority, and then AI will solve the problems. So. Really, he said that last week. It's not that I invented that. He said exactly that. So then sorry for that, but fuck you environment. So now AI is here. So it's like that. And it's super fun. Eh?
I mean, it's probably similar there's another example in your field, which you probably know better than me, but recently in the news, it was that Microsoft has reached an agreement with 3 Mile Island to reactivate a nuclear reactor just for AI.
Mm-hmm.
Exactly, yes.
So yeah, everything we do creates something. I mean, that's, humans basically create them emissions and things like that. So the question is now, and this is a very difficult question to answer. Do we stop the economy? Do we get engineering to work? And in my opinion, it's going to be a mixture of everything. We need to reduce things. We need to improve things. We need to work together and to find the solution. But It's not just one draconian rule of well, no more cow meat and no more fly, and we'd go back to the Paleolithic, and that will solve the climate issue. That's not realistic.
There was a very successful campaign, social campaign, that called people to change their gas personal cars to hybrid cars. And I think this was very successful, even though the amount of emission that hybrid car produces is like comparable, like much more reduced compared to gas. But still, the effect on total carbon emission is still negligible. Okay, it's not as prominent, but the campaign was successful in terms that people realized that there are better and more effective solutions to, instead of typically using gas or fuels that you burn and create power. Do you think like this can be a good solution for Bezos or Taylor Swift, for them to improve the bad press about them? Like just switch your aircraft to something more, or invest into developing this kind of technology that will create us a better aircraft that use hybrid engines or different type of engines. And I think this is something that you are working on. Tell us about this, like, the solution.
I would say in the big picture, in the end, Taylor Swift could fly every single day to have breakfast in two places with an aircraft. She would not have an effect on the climate herself. I mean, it's one person flying. If the big problem is usually scale, when you have millions of people doing something, even if it's smaller. I mean, the example of the AI, it's all of us are using ChatGPT and things like this, and that is actually consuming things. So I think personally, we need to all think about what we do and how it affects things. So take decisions based on what we can do to reduce consumption of energy and reduce everything. At the same time, yes, I think developing technology is the solution, because if in parallel to reducing consumption and making more efficient use of consumption with Second Life and with making more efficient everything we do, we also have technology to also help us reduce that more and more and more, then it's an effective solution. But just one of the two will not work. So personally, if I had the choice, I would say if Taylor Swift could just give millions into technology to actually improve, it would be more useful than her just taking a Tesla to every place she drives and just driving for hours.
And Ignacio, at what level are you in? Because to understand everything, what you are doing is you're creating an electric engine for airplanes. So, but could you explain at what level you are? What are you doing? Could you explain, in correct words? Because maybe what I said is a profanity,
Yeah. So what we do at Dovetail is we try to help with the decarbonization of the aerospace industry by trying to be quick to the market, because aerospace is never quick, and we'll explain to why later. And trying to go into the small aircraft at the beginning, regional aircraft, small short-haul aircraft. What we do at the company is we are developing the powertrain system, which means it's from the motor to the battery, including the control system, so the basic full system, to actually make it a replacement of the turbo machine and put an electric system into it. And for that, of course, we develop batteries in-house. We are working with partners on with the motors. We're working with getting some components from the companies, to make a full system that actually works. We're not developing everything ourselves. I mean, nobody develops everything themselves. There's always partnerships. So yeah, we are at the system level, at the aircraft level, and sometimes at the component level, we design, kind of depending on which one we design those. The aircraft we're trying to start with are small aircraft, what we call CS-23, which are small commuter aircraft for 9 to 19 people. And we are targeting the retrofit market because there's already thousands of aircraft of that type flying, especially not so much in Europe. In Europe, we have very good infrastructures, therefore those aircraft are not used that much. But in Australia, in Brazil, in the US, in places, they actually use quite a lot because infrastructure is not as good. Therefore, these little aircraft are allowed to do little jumps, and they are used quite a lot. So by trying to change those, we might be able to get into the market in the next 2-3 years and start decarbonizing it's going to be at the beginning a negligible effect on the scale of things. I mean, it's not us are going to change the world, but if you already start having companies and having aircraft flying, it's going to be an effect, that you get a snowball effect. It will start growing, technology will grow, therefore there's going to be more investment, and therefore you'll be able to get bigger and bigger. There's companies like Airbus are working on the higher level, trying to get aircraft, the big size, more of what we call medium hull aircraft, something to replace an A320 or an ATR. But those will take longer because they're more difficult to do. This is more and more difficult as you go up in scale. So we're trying to go for the small one at the moment.
Okay. And how is the market these days? Because is there another company doing the same that you're doing? How is the regulation? Because as far as you explained me, regulation is not something simple. Not only in this space, in every space. How is working all these components?
Yeah, maybe the first thing to say is that when people think aerospace, they think one aircraft. They think basically the A320. That's what people think of. Aerospace is similar to when you sell ground mobility. I mean, scooter is the same thing as a long-haul truck. Those are ground mobility, but don't compare one to the other. So in aerospace, the same thing. You have the nice spot aircraft, which are the aircraft that you can take and just fly around with your friends. Then you go into the smaller aircraft, then the bigger aircraft, and you end up with the A380, something that can actually fit 700 people inside and do, transatlantic flights. So those are very different scales and very different ways of working, and therefore the solution also is going to be different. In that respect, each of them will have different solutions, right? So,
but there is another company doing the same,
competition. So I would say there's small companies. There's already aircraft like some light sport aircraft which are electric. There's already one Pipistrel which already has a certified version. You can actually buy it and fly electric. There's gliders and small aircraft that already have something because they're easier to work with, and also regulations are small because it's your own risk. As far as we know, in the market we're in, there's 2 or 3 companies trying to think about these things. There's companies working on electrification of all this. Some are working more into the hydrogen, more into the batteries, more of a combination. So there's different actors in the field, and then of course in the higher field, then there's less and companies. There's some companies trying to go to the regional flights, 70 passengers, 1,000 miles, things like this. So yeah, there's different companies trying to work on. Most of them are startups. Some of them are big companies trying to work out on how to make these things. But it's complex enough that there's no competition right now. Everybody needs to just stand together and make it.
No, because I think it's the same thing that happened with the electric cars. Electric cars, there were one company like Tesla there were previous companies. It's not that Tesla invented that, but there were a moment that Tesla and many other companies start to create electric cars. And at this point is when, everyone accepted that. You can drive with an electric car. And I think that the same thing could happen with airplanes. It's not like, okay, I flew in an electric airplane. So the first time maybe you think twice. Okay, maybe, I don't know, because you have no idea. A person like me is not like a person like you, Ignacio, and you don't know what would happen. But as soon as you see more and more and more, you understand. This is the same that when you are in a Rolls Royce, in an airplane and the engine is Rolls Royce. Because at the end, Rolls Royce, how is doing Rolls Royce engines for an airplane. So at the end, it's these kind of things that when you are used to that, you say, okay, it's normal.
The cloud tech industry is evolving so fast. Do you keep up with it by improving your skills or upskilling your team? At MKDev, we offer a variety of workshops for just that, from the basics to expert knowledge. Before delivering our workshops and training sessions, we carry out a detailed assessment of each participant. To make sure the workshop is helpful for you and your team, we will add more content to it or throw out what you already know. Or we create a custom workshop specifically for the needs of your team and the specifics of your project.
Yeah, definitely. That's why we want to go to market soon. I mean, aerospace takes years to develop, and a full aircraft takes a decade to do, and that would be being quick. Usually the other programs take 15, 20 years because there's so many things to do. That's for a brand new aircraft. So yeah, there's definitely need to work on. And in fact, yeah, one thing is to mention is, we already mentioned this when we discussed, but aircraft are there for a long, long time. If you try to get a new aircraft today from Boeing or from Airbus, you can just pay the 100 million you need to pay for it. you will get it in maybe 3-4 years, or I think maybe now 6 or 7. That's the backlog they have. And then it will operate for 40 to 50 years.
Mm-hmm.
So an aircraft bought today will be there in 60 years, still flying. So it's different from cars in the sense that a car, you buy it now, and if you're lucky, you sell it in 15 years. But that's, when you have got everything you can from it. People usually buy new cars every 5 years, every 4 years. Aerospace is different.
I think we cannot expect a major shift in aerospace industry in the next 50 years. And what you are trying to do is to offer something new that people can, upgrade the existing aircraft with whatever technology you are developing to make this future come faster.
Yeah, in a sense, we're saying that, but also at the same time, we're pragmatic enough to know that we're not going to, we cannot solve all the problems. So in our opinion, the solution to aerospace is going to be a mixture of technologies. So for the small aircraft, you're able to go with batteries for short haul flights at the beginning, and then you need to start putting hydrogen inside in order to make it run longer. And then if you go to the bigger aircraft, the more recent research shows that it's better to actually burn hydrogen in order to make it viable. In the meantime, there's works like the sustainable aviation fuel, which is synthetic fuels or biofuels, which could also be part of the solution by taking back the carbon dioxide and putting it back into the system, either synthetically or with biomass. So there's, in the end, we want to. I mean, in 2 years we're not going to be able to fly you from Paris to New York. That's one thing I can, that's for sure. But yes, we'll be able to start nibbling at that thing and start getting some customers to actually fly electric. Maybe open up some new routes, like flying from in between the Balearic Islands and just from Formentera to Mallorca, just fly electric, because right now there's nothing. You just need to take a ferry. So yeah, we definitely think that we can actually change some aircraft to make it electric. But completely honestly, we will not be able to give you a Paris to New York in the next 2-3 years, or even the next 10 years.
And one question, Ignacio, because one of the main factors, for example, I'm talking about the car because it's the only thing that I know a bit, and I am not a car driver either, so it's imagine myself. But I know that when you have this kind of explosion cars, they are all typical cars, with non-electric cars, it's a car that you can have for 20, 30, 40 years, it's more or less the same example that you were telling to me with the airplanes, you have a car for 50 years. And even if you go to places like, for example, where the family of my wife is in Venezuela or Cuba, you have cars for even 60 or 70 years, It's not a problem. But the question is, when you have electric car these days, the one that it was created 7 years ago is not valid anymore. You cannot use this car because of the way that the car are created, not because of the engine, it's because of the battery and because of the companies. They put all together in one piece. And it's the way that they do that, no? Because it's part of the business. I put all the engine and the batteries all together in one piece. And if you open this piece, then you break the rules and it's not valid. Then as soon as you want something like that, I need to replace everything and put something. Imagine a car of 30K, you need to pay 20K for the replacement of the battery. So then I want to buy a new car.
So I'm not sure I agree with that so much. So the first thing is, the cars that you see running for 60 years, you can change everything because they were so simple that people just, they broke in the road, and you actually change things yourself.
Yeah. Piece by piece.
Now try to do that with a new car. I mean, try to get a Mercedes and try to just in the middle of the street and any car that you can think of, open it up and change something. You can't. There's too much electronics, and electronics are not as simple to change as mechanical things. Electric cars, data shows for the moment that electric motors can last longer than a combustion engine. Batteries do degrade, but they don't degrade as fast as people feared, and therefore, electric car can run for years. It will have less range, but it will still operate, and you can always change the batteries. The reason the battery is so expensive is because the battery has lots of raw material. It's heavy. It's a big thing of the car, but you can definitely change your battery. And in fact, if you're knowledgeable enough, people have changed their own batteries and opened the battery of a Tesla and replace cells. You can actually do it, but I wouldn't recommend it to people who are not experts at that. But the same thing, I wouldn't recommend people to start changing things in a combustion engine of their car if they want it to run. I mean,
my question was, how are you going to try to do in an airplane to be able to make this airplane valid for 20, 30, 40 years? What is the plan on that?
one thing that you may not be aware of is that aircraft, they do have very strict maintenance intervals in order to be safe. We'll come back to the safety afterwards, I think. And therefore, every certain number of hours, you need to take the aircraft and do an inspection. In fact, you do an inspection every single flight. Then depending on the aircraft, maybe every 1,000 hours, which is maybe a month, you need to take the aircraft and start checking everything inside it, and even replacing some parts. That's called the A check. Then you go to the B check, which is done every, depending on the aircraft, maybe 5,000 hours, 6,000 hours, and you start replacing big components. And at some point, you actually replace the whole aircraft, take all the pieces off, and put it back on, and you make it new. And that is true for engines also. The engines, you basically take them off. At some point, you open up completely, take all the little pieces inside. The ones that are serviceable, you clean them up, put them back on. The ones that are not serviceable, you send them back, and you get new ones. So aircraft are always being updated and replaced. It's just that you don't see it as a customer, and we don't do it with cars because we don't want to go to the system all the time. But you're changing filters. But in the aircraft, you actually at some point you change the whole thing. And as soon as something doesn't work, you change.
So it's not that you pay 100 million; it's that you pay 100 millions plus. Later on, you need to continuously
in fact,
see the pieces.
Yeah, I mean, if you take one of the big aircraft, the aircraft costs maybe 100 million. I don't know exactly the price right now for an Airbus or a Boeing, but it's in that range. 1/3 of it is the engines. So you're paying 30 million just for the engines, and then you're probably paying I don't know how many million per month per year. So the engine manufacturers actually have that engine working for you.
It is something you have to take into consideration in your current position. Like you propose products, solutions to the existing aircraft, to the companies, and you have to think like you will need to make maintenance once in certain months, and this is what we do, and this is what we check for. It's like you are creating the plans, what needs to be checked, because why? Because you know what can break in those tools, or
so and this is where, for instance, AI will come in handy in the future. But basically, you already know combustion engine aircraft. You already know the intervals. You know that how much you spend every month on maintenance and how often you need to change the engine and change things. What the cost of that is. What we offer our customers is we tell them your aircraft it will cost you this much to retrofit. And then you will get some benefits because, first of all, you only need to replace the batteries every this often. The motor will be this much this often. So you need to replace things which are going to be less often than the other ones. So you need to integrate that costing. You need to buy a new battery every 2 years and then replace it. The engine will last for 5 years, and then we do a maintenance into it. So there's things like this where you can actually work on. And in the end, it comes up to same thing as a logistics company do. I mean, when you go to a company, you go to trucks, they actually look at the exact maintenance thing they have in order to know how much the system costs overall, not just the purchasing cost, but the cost of ownership. Aircraft do this all the time. It's normal.
And how do you set these intervals? Like based on what? Based on certain materials can only handle so much pressure at a current on this period, and this by testing. You are doing tests on that, and then you make notes like this. Okay, this will break in 5 years, but I will tell my customers to change it in 2, just in case.
Yeah, and that's where rules come in, and where the industry has moved on. So the old way of working, and it's still valid for some systems, is if you want to justify that your system will last for 1,000 hours, you basically test 3-4 times that, and you show that in 4,000 hours it didn't break. Therefore, I'm happy with 1,000 hours. I'm pretty sure it will not break. So every 1,000 hours you change your system, even though it has 2,000 hours of potential life. But in order to be safe, because if the thing is critical and could create an accident, the choice has been made to prefer safety over expenditure in this case. So some things, the old way of working was, you test up to a certain limit, and then you divide that limit by a margin, a big margin, and then you say every this much I replace the system, and I don't care how it is, I replace it. Now more and more, there's with all the power of data analytics, there's predictive maintenance coming in, where if you're able to monitor your system and understand it, you're able to see degradation and say, okay, this system is still running fine, I can wait for the replacement, and you do an unconditioned maintenance, which is much more efficient than just saying, this computer is working perfectly, but it's 1 year old, I'm going to throw it away. You're more monitoring. And this is one of the places where in the industry is actually working a lot. There's even some works on, getting real-time data from the aircraft in order to do a big lake of information in order to understand the way they work. To be able to say, okay, when you land in 3 months, in 3 weeks, you actually need to change this instead of being set in stone. And this is coming. Electrification has the benefit that electric systems, you monitor everything because of the way they work. You have lots of data. In normal systems, you need to put sensors in. In electric systems, getting a voltage is easy. You actually do it, to operate the system. So you already have it. So there's ways where electrification makes it simpler to actually follow that up and do predictive maintenance. But then that's where we actually need all the power of data analytics and to help us with that place. But there's tons of money put into that because it's a big market. In fact, I think MRO companies, so maintenance and repair organization companies, probably make more money than companies like Airbus or Boeing. There's more money to be done in same thing for cars. I mean, I think garages make more money than Volkswagen or Mercedes because of maintenance of cars. Maintenance is something that seems small, but it's actually a huge market, and it's a huge element.
Let's compare the testing part and quality assurance. Because Pablo, correct me if I'm wrong. When we create a certain software or a tool or infrastructure, there is a certain chance that a end user will do something that will broke the system, will crash the application, or crash the entire cloud or something like that. And it is no way for us to predict that because we need to test with million users at the same time to realize that there is a possibility, because we cannot predict what kind of device the end user will use, that how much battery it has, which application it has running, and some bug occurring and everything crashed. But it's okay, because if the application crashed, it's fine. But when the airplane crashed, everybody dead.
It's less fine, yes. It's a bit more.
It's a little less fine.
Yeah.
And you have to predict how.
So in aerospace, there's a saying which is safety first, and that every company in the world that I know of has safety first in their genes. The reason for that is, as you mentioned, I mean, if your phone crashes and you need to reboot it, it's a hassle, but it's okay. If an airplane crashes, it's not okay. It's definitely not okay. So basically what we need to do is we need to make it's what we call quality assurance, design assurance. We need to make sure that what we put in the aircraft is safe. Then there's levels. I mean, for instance, the infotainment system is going to be less critical than controlling the aircraft. So if my infotainment system bugs out and has a blue screen of death, it's fine. I have a grumpy customer, but that's it. I mean, the airlines won't be happy, but the aircraft will not crash. If I have the flight computer of the aircraft deciding that it wants to be upside down, that's an issue. So that's where levels of quality and design assurance come in. So, and this is also why aerospace sometimes seems to lag behind. We cannot take, next example, we cannot take AI and say, okay, AI is not the big hype. I'm going to put AI controlling my aircraft.
Yeah.
Because we have no assurance that it's going to do the right thing in all conditions. So what we need to do at the aircraft level, when we put something, we of course define its criticality based on many analysis on safety and what can go wrong and how can it impact the aircraft. And if it's no problem at all, like infotainment system, then you can do whatever you want. You can put anybody working on that and just I don't want to check it. It's fine. As it becomes more and more critical, and especially for the very high criticality systems like controlling engines, controlling flight controls, landing gears, things like this, which could actually create crashes, then you need to be as certain as you can as that it's safe. And that's where in the past things were more hardware-like, so it was deterministic. You knew that if you had combinations A, B, and C, you actually get result D, and if A fails, it's going to be E. It was simple. You could actually test all the conditions. That's with gates and things like this. And there you could actually be, I'm really sure that whatever happens, I'm safe. Now, as microcontrollers came in, it's more difficult. I mean, it's impossible to know that in every parameter you put in the microcontroller is going to give the good result, and you cannot test that. It's just physically impossible right now to test all the outcomes a microprocessor could could go wrong in terms of changing a 0 and a 1. So what we need to do is to test. So we create there's a huge traceability context. There's a very big process to actually make sure that from what you need to do to what you put in the code to how you verify it, you're really, really certain that you've done the right thing. So you start, straining the software. You start putting failures in, and you try to make sure that everything works, and you make sure that there's no code which is there for no reason, and you make sure that everything is really strong. And that's what allow you to actually trust that your flight control system is as safe as you can make it. And if there's a bug, then because the thing is so critical, you actually put something else which is different, or which is the same but also very high, very high reliability, controlling it so that no single failure can cause a catastrophic effect. And that's one of the things that in big aircraft is that's the basic rule of the airworthiness authorities is no single system failure could create a crash. And that's one thing that should happen that way.
But I wanted to ask, but how do you create those testing scenarios? Because I want our industry, software development, to learn a thing or two from you, because you need to, have a certain level of imaginations to create a countless number of scenarios that might happen during the flight. I don't know, can you predict a passenger will start jumping in the aircraft that will create certain fluctuations to power flow, and the battery will malfunction, and then
Mm-hmm.
Can you even predict this and put this into a scenario and then ask your quality assurance engineers test for this scenario? Do you do that?
That's a really good question, and it's probably complex to answer. So the first thing, I'm not in the software part, so I know that there's very, very, the process to test the software is really strong, very stringent. In fact, for very critical systems, you actually need to have somebody else test your software. Mm-hmm. And what you do is you test every single requirement, every single line. There's ways to do it. I cannot go into that because I'm not brave enough, so I'm going to say something stupid. At the aircraft level, I have actually worked on that. So what you do at the aircraft level is you have an approach which follows also a process which has been established, which is tries to cover everything and is being updated as we speak with industry. Is that you go through two paths at the same time. One is top-down approach, and then is bottom-up. So the top-down approach is you start thinking, okay, what can happen to my aircraft? What are the things that can happen to it? For instance, I could have the pilot loses control, the aircraft just ruptures, or I lose control of the aircraft, or I hit something. There's different scenarios you can think of let's say major events, aircraft events, and you start thinking, what can actually make this happen? And you start thinking, if my aircraft ruptures, it might be because somebody, my fuselage broke, and then what can happen? Well, maybe someone was jumping on the system, and then you kind of identify your failure modes, like who could actually create this, whether this system can fail and therefore create this, or because of a very strange person is jumping in a right model system of the aircraft. In parallel, you also start thinking for every component, you start thinking of how can this fail? This thing can fail, it can just burn off. It can just start becoming crazy and have something that doesn't work, or it can actually start degraded mode and, have less power and therefore be slower. And then you start seeing the cascading effect, and you analyze this cascading effect, and then you try to link both together so that at one point, all the failures that you think of are linked to the aircraft failures in that top-down and bottom-up approaches. And then when you have all those identified, then you can start thinking, okay, if I've understood that a person jumping at this specific frequency can actually break my aircraft. And therefore, your stress engineers will then say, okay, this is due to a specific mode in the aircraft. I'm going to change that mode and make it so that there's no way somebody can jump in a way that breaks my aircraft, because the aircraft is either so strong that it doesn't care, or the frequency he needs to jump as is just impossible to do for a human. And that's where it comes into different people working together. But yeah, it's definitely understanding your weak points and working on them, either by putting margins or by removing them completely or by mitigating the effects. And you basically work on that for every single thing you can think of. And that is true for, losing power, fires in the aircraft, losing the lights, all these things. You need to think about every single thing that can happen. And even one of the things that people think of is, evacuations. I actually have never been in one of the evacuation tests that they do, but I know that you can be volunteering and you can actually do it. And from what I've heard, you need to evacuate the aircraft in a certain amount of time. That's a regulation. They tell you need to be able to, as soon as the pilot says evacuate, everybody in the aircraft needs to get out of the aircraft in, I think, I don't know how much it is, but maybe 60 seconds. I don't know how much it is. I may be wrong, but it's about that time. And when they do the test, the authorities will be there checking, and they will also define a set of people. They will tell you, you're going to be the person who always gets to get his bag. So you're going to be like a grumpy person, and you're going to be the person who is crazy and doesn't answer, and you need to actually drag him, so that it's not just everybody just going up and evacuating. It's actually some people are actually theatrically making sure that they make the wrong thing, so they actually just show that actually works. So there's things where you actually strain the system by putting the things that you can think of. Of course, there's always things you cannot think of. Maybe there's a snake in the plane. You cannot think of that, but every time you think about something, you kind of put it in and try to make it work. So that's basically any idea to strain the system is good, and then you either put it in or you disregard it. But that's the way to try to be everything safe.
Ignacio, one question, because this is something that when you explained me was for me something like shocked me. Because when you are in an electric car, one of the most important things is the noise. There is no noise. So you are driving the car. I am not, but I am the co-pilot. But okay, and there is no noise. It's a quiet car. And what happened with an airplane? Because you can imagine, okay, I am in an airplane because all of us, we have been in an airplane, even with these headphones. I was yesterday flying in from San Sebastian, from Bilbao to here to home. And then it was impossible to hear the music because there is no noise cancellation in these headphones. And then it was impossible because I was really close to the engine and impossible to hear anything. So explain me, what's happening in an electric engine and why?
So the first thing we need to say is that if you've been in an electric car, there's definitely no engine noise, which is very nice. I mean, I have an electric car and it's really quiet. But when you're running at highway speeds, you still have noise from the wheels and from the air. Air actually creates noise, and in fact, it can be worse than the engine noise. So in an aircraft, you will have also a combination of noises. One is going to be the turbo machine, the combustion, just that roar that is behind the engine. That's going to create a lot of noise. And in fact, and when you know the engines, you actually recognize the engine by just the way it starts and the way it roars. You can actually, if you've been too much into it and you're a geek, you can actually do it. Then there's noise of just the air flowing through the aircraft, because the air creates turbulence, and that turbulence creates noise. So lots of the noise you hear is actually the air going through. And then in propellers, you also have the propeller creating also this turbulence and therefore creating noise. So what it is true that, and that's one of the things that we're selling also, the aircraft we're going to sell are going to be quieter. They're not going to be whisper quiet. I mean, there's not going to be just zero sound, because there's still aerodynamics and there's still propellers. But you will not have, we're removing that whining or roaring sound depending on the engine that can be very frustrating. But, it's one point we can do. We can actually reduce the decibel level so you're more comfortable. Or even some cities are actually complaining about noise. So you might be able to operate closer to the city and therefore have an airport closer and small airfield, because they will not be as noisy, and therefore you can operate them. So there's more and more regulations, because people, I live in a place where you actually hear the airplane flying by, and therefore, I know where it is. If they can be quieter, everybody's happier. So it's one of the benefits of electric flight also. You're removing that noise. Not true for hydrogen burn, of course. Hydrogen combustion will have the same roar as the other ones. But everything which is electric or even hydrogen fuel cells will be whisper quiet. In terms of engine, then of course there'll be other factors. So it will never be super insulated, because in the end, in the aircraft, weight is king, because every kilogram that you put on the aircraft, you need to lift it. In a car, it's very simple. If you have 100 kilograms more, you just, you drive, you still have the ground holding you. So the wheel just have a bit more pressure, but you're still on the ground. In an airplane, you need to actually lift that off. So you need to create a force which is equivalent to the added weight. And in order to create the force, you need more energy, more power. So in order to fly with heavier equipment, you need more energy. And more energy means more battery, for instance, or more fuel, more hydrogen. Therefore, you need to become heavier. And it's a vicious circle that comes in. And this is why, for instance, a battery electric A380 doing Singapore to London is right now just not possible. When you make the numbers, the physics don't add up, because of the fact that you need to put some more weight that for the power that you kind of become that thing. technology will hopefully be able to get closer and closer. But right now it's not the case, because in airplanes, every kilogram that you lift is a kilogram you need to move.
And even for my case, I live in an island. So when you need to jump from one island to another island, so I need to use these little airplanes, super little airplanes, with these, I don't know how to say it in English, it's turbohélice, this turbo...
Yeah, turbopropeller.
Turbopropeller. You know, that is all airplanes, you know, is the one that you see in this, and those are super noises.
That is the type of aircraft we're working on. So the plane you take, the plane you take for your little islands is the type of plane we want to modify first. And exactly one of the markets we want to go in. So we're going to go into the markets which are at the beginning, it's a niche. I mean, as mentioned, it's not a Paris and New York. It's going to be skydiving. It's going to be scenic flights. But also, to me, the most interesting one is island hopping, fjord hopping, where right now it's not workable because it's it's expensive. It's noisy. You need infrastructure, and also it doesn't work economically. But if you have airplanes which are zero emissions, which are quieter, and which also are cheaper to operate, then suddenly you might be able to create these air taxis that jump from island to island and communicate places which are not well communicated. That's one of the places we're actually working with, and we have some interested customers who actually do that. They're actually interested in doing island hopping or connecting islands to mainland, and that's the type of places we want to start. So you might be one of our first customers.
This could be fantastic, yes. No, cool. Could be fantastic. For me, I fly a lot, and then for me, take one of those could be fantastic, because when you're jumping to one short place, because at the end is in cases it's like 80 kilometers, something like that, and even less in many cases of the island. So it's it's nothing. So
it's exactly similar to the fjords in Norway. You can jump from one city to the other in 10 minutes with an aircraft. If you take a car, it's going to be 5 hours because you just need to go to the end of the fjord and come back. So that's the places we want to start using our aircraft and start decarbonizing that.
We started with your idea, your dream to make a world a better place to live. That's why you get into engineering. Let's finish on the similar note. Tell us about a future, briefly. Is there a consensus in your community and the engineering space you're working at? What we are aiming for today and what we can expect in 10 and 50 and 100 years? Very short.
So I think there's no big consensus, but again, because as mentioned before, there's not going to be a one solution fits all. In my opinion, and probably people will not everyone would agree with it, it's going to be a combination of things. So the first thing is sustainable aviation fuel is going to help us bridge the gap for the big aircraft for the moment. People will still need and want to fly. I mean, the economic way we have now means that we need to ship things from places to places. We need to fly to places. And it's really, I think it's opened up the world that you can actually know other cultures and fly there. So those places will probably need to go into the sustainable aviation fuels. At the same time, batteries would be able to open up those small markets, those short haul routes, and be able to start allowing for making jumps between cities which are not well connected. And instead of having just highways, you can actually have the little planes for some things, and connecting places which are more difficult to connect, like Salzburg and Switzerland are not far away, but you have the mountains in the middle. So you need to go to Munich and then go back. An airplane could actually do that very quickly. So there's other things that we can actually work with and create something. And at the same time, then there's all the technology working on the hydrogen. Hydrogen is the lightest molecule we can get. It's also very energetic, so it's a very interesting one. And there's different ways to use it as a fuel cell or as a combustion engine. So I think there's going to be, in the end, it's going to be a mixture of all of them becoming decarbonized aviation in the coming, and it will start slowly, and then hopefully will take more and more momentum and become bigger and bigger. And maybe in 100 years, a new technology will come in, and now maybe mini fusion reactors will come in, and then we'll be able to put those in our aircraft. But right now, we don't see other solutions in the horizon. I mean, I'm hoping somebody can actually find something else. But right now, the ones we see are those three, basically: hydrogen, batteries, and SAF as the main ones. But they need to be a combination. They cannot do it alone. None of them is going to solve the problem, in my opinion.
Cool. Great. Thank you. Thank you for sharing this. Thank you for coming. I hope those who listens to us made a lot of notes, especially on the quality assurance part. We learned a thing or two. And thank you for this look into your industry. It was magical. Thank you for coming, Pablo. Thank you for joining too. Those who listens to us, thank you for joining. Don't forget to like and subscribe, and we will hear you and see you in 2 weeks. Bye, everyone.
Okay, thank you for having me. Bye.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.